What's in a name? Everything. The power of a name has long been immortalized in prose, poetry, and history. It is your face to the world, your ambassador of quality that reflects your ideals and aspirations. Thompson's, a name, a family, a tradition of excellence. So it is with Thompson's Toyota, where our professional and courteous staff are eager to help you drive home your dream vehicle from the largest selection of new and used Toyota cars and trucks at the best prices. And if your vehicle needs service, our Toyota factory-trained and certified service technicians have the skill and expertise to do the job right and do it right the first time. Thompson's Toyota, where you'll always be treated like family.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
Why Curiosity Matters, presented by Science at NASA. Adam Stelzner doesn't sound much like an ordinary engineer. For instance, when we asked him if he would talk about curiosity and explain why the Mars rover matters to ordinary people, the former rock and roller responded, "I'm totally down with that." He really is down with that. Stelzner is the NASA engineer who helped take the country's new Curiosity rover to the surface of Mars with moves and flair even Evel Knievel would envy. Stelzner begins, "I'm so thankful to Clara Ma for suggesting the name Curiosity. It embodies a fundamental attribute that defines us as humans. Why do we explore? It's our nature," he says. "Human curiosity is why you and I can talk across the country by phone. It's why I'm sitting 60 feet above the ground in a building made of alloys and other high-tech composite materials. We dominate this planet because we wonder what's around the next corner." When people ask Stelzner, "Is the new rover worth $2.5 billion?" he has a compelling answer. It's not $2.5 billion we stuffed in a trunk and blew into space. It's thousands of high-tech jobs spread over 37 states. It's honing and developing our skills in science, engineering, and math. He notes that the U.S. has slipped to 14th in science education and 18th in math, in a world where we're competing for economic prosperity with nations 1 through 13. This mission is an investment in high-tech jobs and inspiring the youth of our country and stepping up, rung by rung, towards first place. It's the best stimulus you could imagine. Okay, curiosity matters, but does it matter more than rock and roll? Stelzner played guitar in a rock band for years, so he has the chops to answer this question too. In some sense, exploration and music are both art forms, he says. They're both expressions of our humanity, but exploration can surprise us more, or at least differently, than music can. Music can surprise us only about what we find in ourselves. Exploration surprises us with what we learn of ourselves and of the universe. Stelzner says music led him to exploration. During high school, he played in a rock band. One night driving home from a gig, he noticed that the constellation Orion was in a different place than it had been before. But why? I hadn't paid attention during high school classes at all, so I didn't know. His curiosity made him decide to take an astronomy class. First, though, astronomy had prerequisites such as elementary algebra and conceptual physics. He took them all. I basically redid my high school education at the community college. The rest, which includes a bachelor's degree from UC Davis, a master's degree from Caltech, a job at JPL, and a daredevil landing on Mars, is history. After the glory of the Curiosity landing fades, what will this explorer do next? Our solar system offers us grand challenges, says Stelzner. I'd like to see a Mars sample return. I'd like to land on the surface of Europa, the most likely place in the solar system for life. And third, I'd like to float a boat on the methane lakes of Titan. The solar system is calling out to us, he says. The wind's at our back. It's time to explore. We're totally down with that. For more science news that matters, visit science.nasa.gov.
Where Will Curiosity Go First? Presented by Science at NASA. By now, it's old news that NASA's new Mars rover Curiosity is resting safely on the surface of the red planet after a daredevil landing that had the nation holding its breath. Now, mission scientists are anxious to start moving. With such a sweet set of wheels at their disposal and the open road before them, just where will they go first? We won't have to travel far for excitement, says project scientist John Gratzinger. We landed in the best possible place within the landing ellipse, the bottom of an alluvial fan. An alluvial fan is a pattern of sedimentary rocks, dirt, and sand deposited by flowing water. In this case, perhaps an ancient Martian river. Since life as we know it requires liquid water, this is an excellent first place to search for clues of a Mars that was once hospitable to life. The alluvial fan indicates that water flowed across the surface, so we'll head downhill to where water might have collected. We'll be looking for minerals like salts that might tell us where water has been. It's kind of like a scavenger hunt, with minerals as clues. After that, Gratzinger says it's full speed ahead to the base of Mount Sharp, a 5,000-meter-tall mountain that holds within its ancient layers possible clues to life on the red planet. We'll have to make a deal with ourselves not to stop too often along the way. Mount Sharp is the reason we chose this landing site, so we need to hightail it on over there. Deputy Program Manager Richard Cook describes the temptation to stop along the way. It'll be like taking a family vacation. But instead of the family, you have 400 scientists who want to stop and look at every site. Curiosity is bristling with instruments custom-made to look for the chemical building blocks of life. A laser on Curiosity's mast can take aim at interesting rocks and vaporize small spots on them from up to 7 meters away. The microblasts produce plasma clouds, and the scientists can examine the light reflected off of these clouds to learn what the rocks are made of. The mast also sports a high-resolution camera called MastCam, which has already begun observing and photographing the rover's surroundings. The rover's robotic arm wields its own array of instruments. The alpha particle X-ray spectrometer will measure the abundance of chemical elements in the dust, soils, rocks, and samples the rover gathers. The Mars Hand Lens Imager acts like a geologist's magnifying lens that can take its own color photos. Ultimately, samples will be delivered to a pair of onboard laboratory instruments. One of them, SAM, short for Sample Analysis at Mars, will explore the red planet by sniffing the air, bird dog style. It has vents for sniffing the atmosphere and detecting gases like methane. SAM can also sniff the gases released by rock or soil samples it heats in its own oven. Can 400 scientists gripped by the thrill of the greatest family vacation ever really rush to their destination without stopping to savor every sight? Gratzinger makes just one guarantee. In the coming months and years, Curiosity will tell us an incredible story. For more postcards from Curiosity as it travels the red planet, stay tuned to science.nasa.gov. Curiosity, the Stunt Double, presented by Science at NASA. With a pair of bug eyes swiveling on a stalk nearly 8 feet off the ground, the 6-wheeled, 1,800-pound Mars rover Curiosity doesn't look much like a human being. Yet, right now, the rover is playing the role of stunt double for NASA astronauts and making an excellent impression. Curiosity is riding to Mars in the belly of a spacecraft where an astronaut would be, explains Don Hassler of the Southwest Research Institute in Boulder, Colorado. This means the rover experiences deep space radiation storms in the same way that a real astronaut would. Indeed, on January 27, 2012, Curiosity's spacecraft was hit by the most intense solar radiation storm since 2005. The event began when sunspot AR-1402 produced an X2-class solar flare. On the scale of solar flares, X-flares are the most powerful kind. The explosion accelerated a fusillade of protons and electrons to nearly light speed. These subatomic bullets were guided by the sun's magnetic field almost directly toward Curiosity. When the particles hit the outer walls of the spacecraft, they shattered other atoms and molecules in their path, producing a secondary spray of radiation that Curiosity both absorbed and measured. Curiosity was in no danger, says Hassler. In fact, we intended all along for the rover to experience these storms en route to Mars. Unlike previous Mars rovers, Curiosity is equipped with a radiation assessment detector. The instrument, nicknamed RAD, counts cosmic rays, neutrons, protons, and other particles over a wide range of biologically interesting energies. RAD's prime mission is to investigate the radiation environment on the surface of Mars, but researchers have turned it on early so that it can also probe the radiation environment on the way to Mars. Curiosity's location inside the spacecraft is key to the experiment. We have a pretty good idea what the radiation environment is like outside, says Hassler, who is the principal investigator for RAD. Inside the spacecraft, however, is still a mystery. Even supercomputers have trouble calculating exactly what happens when high-energy cosmic rays and solar energetic particles hit the walls of a spacecraft. One particle hits another, fragments fly, the fragments themselves crash into other molecules. It's very complicated. Curiosity is giving us a chance to actually measure what happens. Even when the sun is quiet, Curiosity is bombarded by a slow drizzle of cosmic rays, high-energy particles accelerated by distant black holes and supernova explosions. In the aftermath of the January 27th X-flare, RAD detected a surge of particles several times more numerous than the usual cosmic ray counts. Hassler's team is still analyzing the data to understand what it is telling them about the response of the spacecraft to the storm. More X-flares will help by adding to the data set. Hassler expects the sun to cooperate because the solar cycle is trending upward toward a maximum expected in early 2013. As of February 2012, we still have 6 months to go before we reach Mars. That's plenty of time for more solar storms. A stunt double's work is never done. For more news about bug-eye robots and other things in space, visit science.nasa.gov.